Personally, I think the measurement questions in paper 2 are a lot harder than maps and plans. And we had a look at some complex measurement questions in that bootcamp last weekend. So hopefully you've got an idea of kind of what to expect. But I would definitely say that maps and plans in paper 2 is where you can bank your marks. What's going to be important is just that you read your questions carefully and that you look at the addenda, annexures, whatever it's called. You look at those things that they give you very, very carefully, because a silly little question, say, for example, like being given a floor plan and being asked how many doors are there, is going to be very much dependent on you counting the doors correctly. All right, so it seems like such a silly statement, but it's just one of those things that, like, it's where we make the silly mistakes, and so we must just be very careful when answering our questions. All right, but like I say, we're going to get into maps and plans, and then hopefully have some time at the end for any questions that you want to ask me about MathsLit. So let's get into it so that we've got time to do that. All right, so just in terms of the section, a few things you need to be able to do, or a few things that you're going to be confronted with, and just to like prepare yourself for it. You're probably going to be given some type of map. It might be a road map. It might be a map of a specific area. I know one year they did a map of, like, I think it was like a section within the Kruger Park, or some park place, I don't know, something like that. You're going to get something like that. You will likely get something that has to do with building an item. So building a chest of drawers, putting together a chair, putting together, I know there was one a while back with like a dog kennel. So putting together pieces in order to make a whole. And then, like I say, you're going to have to be able to work with some sort of scale. Often what that is going to involve is you needing to measure. So make sure that you have a ruler with you. They do say for MathsLit, have a piece of string with you. I wouldn't say that's like a must. Like, don't go and panic if you don't have string. But if you do have like string or ribbon or something, take it with you just in case. Just because sometimes the distances or the lengths they're asking you to measure is a bit windy. And so trying to do that with a ruler is tricky. Oh, excuse me. I'm going to be honest, I usually do it with a ruler because I never have string with me. However, just like grab some string, some yarn, something, if you can. You don't need something massively long, like 30 centimeters is more than enough. It's just like I've watched kids pull out hair to try and measure curved distances, and just don't do that. Just have it with you. Rather have it and not need it than need it and not have it. It's not very often. I think they've also, I think that the examiners have also tried as far as possible to make the distances that you measure relatively straight, or ask you for straight line distances, just because it's not always accessible to have, like I say, string, ribbon, yarn, whatever on you. And so they have tried to make it a little easier for everyone to be able to answer the question. But my advice is, if you can, take some along with you in your paper 2 exam, and then just keep it for finals. Like I say, you don't need a lot, like 30 centimeters should be more than enough. And you then should be sorted in terms of your measurements. Okay. So those are sort of like the things that you're going to see here. Paper 2 also has a lot of annexures, addendums, I call them annexures, but addendums wasn't in my head, so I was getting myself confused. They call them annexures. There's a fair amount of them in paper 2. Paper 1 a little bit as well, but more so in paper 2, just because of the maps and plans section in particular. So please make sure you are looking at your annexures that you have been given. In the instructions of your exam, I don't have them now, but in the instructions of the exam, it generally does say you have an annexure, and then it does list which questions have the relevant annexure. So for example, they would say annexure 1 for question 1.3, and then you know to match them up. But again, in the question, it does say on annexure A, you are using the situation. So just make sure you are always referring back to those annexures as you're going along. It all seems like very straightforward stuff and like obvious stuff, but again, in the moment, you're sitting, you're writing an exam, it's been a stressful week already with other exams. It's important to just, do the basics right, and then you should go quite far. Alrighty, so let's have a look at this one. So this was from last year's mock exam in the Western Cape. So Aldred and his son decide to travel from their home in Van Rensdorp in South Africa to Keetmanshoop. I don't know if I said that very well. Keetmanshoop, whoop, in Namibia for a hunting expedition. On Annexure A is a strip chart indicating their route. Okay, so a couple of things. This is our strip chart over here. Okay. Bear in mind that they told us that they are traveling from their hometown to Namibia. So just take note of where they're going or where they're starting from and where they are going to. So for example, if we look at the strip map we've been given here, whoopsies, I'll make this highlight a little bit bigger. This is going to be quite sad. Here's their hometown, Van Rensdorp, and here is Keetmanshoop in Namibia. So that is their starting point. This is their ending point, and we can then go from there. The strip map we've actually been given, though, starts all the way down in Cape Town and gives us a route along a major highway all the way up into Namibia. But we can look at that if we need to look at that, but just sort of identify for yourself which part of the map the context is referring to. Right, have we all seen a strip map before? You can give me a thumbs up or shout yes or whatever. Have you seen one of these maps before?
Yes, ma'am.
Yes, ma'am.
Okay, cool. So we kind of know what it's indicating. They can be presented in a couple different ways. Some strip maps are quite complicated. I remember when I first looked at one, it took me a little while to figure out what was going on. This is a little clearer, but we know that strip maps basically give us a portion of a route, and they give us the distances when traveling from a certain place or away from a certain... Oh, gosh, sorry. Chaos. Away from a certain place, they give us sort of incremental distances from one place to another. And it just gives a nice idea if we are at a certain point, how far away we are from our destination or how far we've traveled from our starting point. All right, so I'm going to ask you guys to answer a few of these questions because hopefully we're relatively straightforward. And the first question asks, what do the distances on the right of the help if I could read the question. On the right of the end, guys. I'm going to try one more time. Otherwise, you're going to read it by yourselves and then you can answer the question. Okay. What do the distances on the right of the N7 indicate versus the distances on the left? Okay. I feel much better about myself after being able to read that sentence for the third time. This is the right-hand side. This is the left-hand side. So clearly, even though they're pointing to the same position, they represent different things. On the left, I've got a 0 kilometers, but on the right, I've got 995 kilometers. So they represent different things. Can either of you tell me what they represent? And if you need, let's do that. So
Maybe is it the kilometers, like it's the distance?
Mm-hmm.
From that place?
Yes, okay, perfect. Yes, exactly, 100%. So these distances on the right, remember I said earlier, strip maps you can read in two different directions. So for example, on the right-hand side, if we go all the way to the bottom to Cape Town, this is starting at 0 kilometers. So all of these distances along or up the right-hand side of my strip map, these all tell me how far away I've traveled from Cape Town. Whereas on the left-hand side of my strip map, I started at 0 all the way up here at Keetmanshoop and go all the way down 995 kilometers to Cape Town. So we're reading them in two different directions. So one is distances from Keetmanshoop to Cape Town, and the other is from Cape Town to Keetmanshoop. Guys, English, Afrikaans, nothing's happening for me today. So distances. So if we just start with on the right, you can start with either one. It doesn't matter. Obviously, you would need to write in full sentences. I know that seems a bit silly, and we are relatively strict about it when we mark. So try and put it in full sentences. It doesn't have to be a very wordy sentence. Just get your point across and move on. So the distances on the right indicates our distances traveling from Cape Town. Don't know why I decided to go in capital letters all of a sudden, but anywho, there we are. Whereas the distances on the left indicate our distances from Keetmanshoop, or you could say to Cape Town. But obviously, because these are our starting and end points, it is nice to use them where possible. Right, so exactly they are our distances from a certain place to another. And that's why a strip map is quite useful, because you can read it in two different directions. Right, so 1.3.2 says write the distance from Cape Town to Keetmanshoop in meters. So firstly, how many kilometers is Cape Town to Keetmanshoop? What's the total distance? Atia?
Is it 600? No, wait.
So remember Cape Town all the way down at the bottom here, Keetmanshoop all the way at the top here.
From Cape Town to 995 kilometers.
Nice. Okay, so the whole 995 kilometers. Now that's not what the question asked me to do. It asked me to put it in meters. So now, and this is what I was saying earlier, we bring in a lot of measurement knowledge. Now we need to convert from kilometers to meters. Can anyone remember how many meters there are in a kilometer?
Is it 100?
A
Wait,
bit more?
1 kilometer. Oh, if you're getting meters, 1 kilometer.
Yes. So how many meters are there in 1 kilometer?
Is it 1,000?
1,000. Excellent. Good. So we've got 1,000 meters in 1 kilometer. Now, I spoke about this on last week, Saturday. Remember, we could also use King Henry. So King Henry died a miserable death called measles. And then you pick the units you are obviously trying to convert to. So we are going from kilometers to meters. We're going from big to small in terms of a big unit to a small unit. So therefore, we are going to have to times or multiply. And every jump that we make is a multiplication by 10. So times 10 times 100 times 1,000. So every jump we made was a multiplication of 10. So that's why if we were going to convert here, we would just times by 1,000. And that would give me how many meters, which is 995,000. Obviously, if you wanted to use our little table, that's absolutely fine as well. You do obviously need to know the conversion, but we put in our 2 units that we're working with, kilometers and meters. You write down your conversion. So 1 kilometer is 1,000 meters. And then you put in the value you are wanting to convert, our 995. And then you go and do our little trick, divide up, times across, and you get exactly the same answer. So you must do whatever you're comfortable with. There's no reason for you to use a method that you're not comfortable with. You do you. But there's a couple different ways that you can do it. So either you just know the conversion and you know to multiply. You can use King Henry, or you can use the trick method. And guys, remember I said the trick method is particularly useful, especially if you don't know whether to multiply or divide. So sometimes it is a bit tricky to know, okay, should I be multiplying by 1,000? Should I be dividing by 1,000? Which operation should I be using? The trig method kind of gets rid of that confusion for you. It's always going to be divide up times across. And so as long as you know your conversion, you plug it in and you get it. You don't even have to think about whether you should times or divide. Okay, 1.3.3 says calculate the distance that Aldred and his son must travel to reach Keetmanshoop if it is 2 kilometers from their home to the main road. Okay, so let's just understand what this is saying to us. Our main road to which they are referring, so main road, is quite literally this main squiggle of N7B1 down the center of my map, okay, that I've badly highlighted in orange. What they're saying to us is, remember, their little house is here in Keetmanshoop. That's what we were told. Terrible house, but whatever. Also, no, in Van Rensdorp. And their house is 2 kilometers from the road. So they have to drive from their house 2 kilometers to get onto the N7. Once they're on the N7, they're now traveling all the way up into Namibia along the B1 to Keetmanshoop. So we now need to figure out what the distance is from this point all the way up to where we need to be. Okay, now remember, the distances along the right-hand side are telling us how far away we've traveled from Cape Town, and the distances along the left-hand side are telling us how far away we've traveled from Keetmanshoop. Now, we always just need to be very, very careful in terms of making sure that we're working with the correct distances, we're working with the correct values. Another thing we need to be very careful of is that the lines match up on left and right hand side. So, for example, of course, all of them are absolutely fine. So that's a somewhat irrelevant point. But okay, here, for example, let's just make sure I can do some maths real quick. So for example, over here on the left-hand side, if you go and have a look from Cape Town to Piketberg, I'm probably saying that wrong, I do apologize to anyone from there. The difference between 867 kilometers and 995 kilometers is 128 kilometers. Whereas from Cape Town to a point just above is 130 kilometers. So just be very, very careful that you are working with the correct distances here. And so this 695 kilometers is not quite at Van Rensdorp. So we want to be using the 300 kilometers that is quite literally indicated right there at the town we want to start at. Okay, so again, if we just understand what's been said, from 0 to 300 kilometers, this is telling me that Van Rensdorp is 300 kilometers away from Cape Town. We know that Cape Town is 995 kilometers away from Keetmanshoop. So we could go and work out this distance from Van Rensdorp to Keetmanshoop by subtracting those two values. So we can say, okay, well, we know the total distance is 995 kilometers. Obviously, they're not traveling from Cape Town. So those first 300 kilometers are not relevant to us. We need to take them away. They're traveling from Van Rensdorp to Keetmanshoop, not from Cape Town. So those first 300 kilometers don't matter to us. I don't need that. And what we need to remember is that they still needed to travel 2 kilometers from their house to the main road. So we need to add on 2 kilometers for them to travel from home to the main road, N7. 995 minus 300 is 695, plus 2 is 697. Can I not do math? It's entirely possible today. No, I can do math. I don't know why I'm panicking. 697 kilometers. All right, so just take careful note of which distances are and aren't important to you. And if you are unsure of which side to work on, go to the distance that is on the side of the town or the place or the point or whatever that you are concerned with. So because Van Rensdorp is listed here on the right-hand side, I use the measurement on the right-hand side. Just because sometimes they are slightly off on the left and right because there's slight distance differences. And so we just need to be very careful of that. And like I say, if you're not sure, rather just work with the distance that is on the side with your town, your position, your point, whatever it may be. Okay, so 697, that is how far they traveled. This is also a point at which we could throw in like a speed, distance, time question. So for example, I might say to you something like, I don't want to make this unrealistic, so let's just... okay, so for example, I could say that they traveled at 100 kilometers per hour. How long did it take them? Obviously, the question would be worded much better than this. But I could throw in speed, distance, time here. And this is now where we need to know our formulas. I don't know how many of you have seen this little triangle before when it comes to speed, distance, time. But this is actually very, very useful to you if you haven't seen it for speed, distance, time questions. So speed is equal to distance divided by time. So this horizontal line here represents division. So distance divided by time. And basically, if you want speed, you then read the other two values. So we want speed, we would then read distance over time. If, for example, I wanted distance, I would then read speed times time. So the vertical line at the bottom represents multiplication. So the question is asking how long, that's looking for time, which means that in this beautiful little triangle that I've drawn, we're looking for t, which is distance over speed. So we would take our distance, which we've just worked out to be 697 kilometers, divided by our speed of 100 kilometers per hour, and that gives me 6,97 hours. Right, so we could throw in a speed, distance, time question here, so just be mindful of it. If you don't know this triangle, if you don't like this triangle, just remember speed is equal to distance over time. Sometimes if we ask you these questions, we do actually give you this formula. And then you just substitute in what you know. So you know the speed, you know the distance, it was 697. You're looking for the time, and then you would have to go and solve the equation. So this is why I don't always like not working with the triangle. I think the triangle is much easier because sometimes solving your equation just isn't like very nice. And so knowing the triangle, it means that you can automatically isolate the variable you're wanting to work with and go from there. If you did have to go and solve this equation, you would first have to multiply by t on both sides. So 100t equals 697, and then divide both sides by 100, which would give you exactly the same answer. So it doesn't matter what you choose to do. You decide. But like I say, this is a point at which they could ask you a speed, distance, time question. Then we need to be able to answer it. Right, any questions so far for this one in particular? Good. Just give me a thumbs up.
No, ma'am.
Cool. I assume you guys will let me know if you've got questions, so you're very good about that. So you will let me know. All right, so it says in 1.3.4, write down the road number on which they will travel when they are in Namibia. Now, I've actually already said it, but if we look at our map, what is the road number that they'll travel on when they get into Namibia?
Ma'am, is it B1?
Nice. Okay, good. B1. So here's Namibia. They've crossed over into the border, and it basically changes from N7, which is how we label our roads, into Namibia B1. Perfect. Easy 2 marks, sorted. 1.3.5 asks how many towns did Aldred or would Aldred and his son pass through while traveling through South Africa? So now we need to count the number of towns that we have along his route. Again, remember, but from Van Rensdorp to Keetmanshoop. So we've got 1, 2, 3, 4 at Springbok, 5 Port Nolloth, 4 6. Okay, let's make sure we've got that right. Read my question again. While traveling through South Africa. Oh, no, see, this is why it's so important we read the question. No, that's right, 6, sorry. No, this is at our border, so we're not counting. I don't want to try to say that because I would butcher it, and that would be embarrassing for everyone. We're not counting this because this is at our border, so we're already at the border to Namibia, and it asked specifically while traveling through South Africa, specifically South Africa. Okay, so we had 1, 2, 3, 4, 5, 6 towns that we need, or that they would travel through. So guys, like I say, like often these questions for maps and plans is very much counting or reading information off your map. So not hard questions, just questions that we need to look carefully at our annexures, our maps, whatever the case may be. All right, so that's an example of a strip map. It's also an example, we've spoken about the levels of questioning in your paper. How question 1 is generally a very basic question aimed at or covering everything to do with your paper. So for example, in paper 1, it'd be a finance question, a data question, maybe a very easy probability question thrown somewhere in there. Paper 2 would be a maps and plans question, a measurement question, and probably a probability question somewhere in there, but all at a very basic level. Reading information off a diagram, doing a basic conversion, etc. When we then get into question 2, 3, depending on how many there are, this is now where we get more specific about what we're looking at. So question 2 is generally a maps and plans question. Question 3 is in a measurement question. And then question 4, and sometimes I throw in a question 5, but it's usually up to question 4, is then a combination of the two. Can think. That sounds to be correct, but I'm pretty sure we did one of those with measurement. But if not, we'll have a look here. All right, so this is from 3 years ago, finals. Again, there's an annexure. And it says, Annexure A shows the floor plan of Jan's house with a veranda in South Africa. So a veranda is also known as a porch or stoep. It's an open area with a roof over it. Okay, you'll see that oftentimes if there is wording that we expect you to know for the question, but maybe it's not something that everyone has knowledge of or has context for, there's a little definition for you. There was a definition a little while in one of the other ones that we did, and obviously now I can't remember it, but there was a definition for something as well in one of the other papers we've had a look at. So just if you're ever confused, it might be there for you. So the following is an artist's drawing of one of the elevations of Jan's house, and then Annexure A has the floor plan. Right, remember you get floor plans and you get elevation plans. Elevation plans give us a side view. So what's nice about this is these elevation plans will represent or will show us the height of our structure, whereas a floor plan only gives us 2D dimensions, the length and the breadth of a room, whatever, but it doesn't tell us how tall the building or the structure will be. This is why an elevation plan is very useful for us. All right, so this is Annexure A. It's got all of this stuff here. Importantly, we have been given a key. So if we're not sure about what something represents, we can see. Doors open, and doors are generally like an open D shape. I don't really know how else to describe them. Windows are generally like a clear white rectangle in a wall. So you can see here what I mean by that. There's the rectangle in a wall that represents a window. Sometimes we have other things that we put there in your key that maybe represent certain features or whatever the case may be. But generally speaking, everything else is straightforward. So for example, in the master bedroom, we can see there's a bed. That makes sense. It's a bedroom. Okay. In the kitchen, we can see that there's a sink and a stovetop. Makes sense. We're in the kitchen, etc., etc. We can also see that veranda, which they spoke about earlier, on the bottom right of our floor plan. And then we've got everything that we need here, and we can go and have a look. So the first question says, write down the number of bedrooms on the floor plan. So how many bedrooms are there, guys?
Three, ma'am.
3 bedrooms. Good. We've got the master bedroom and bedroom 1 and bedroom 2. The next question says, which room will be the first room you will enter from the veranda? So what do you think?
Wouldn't it be the living room because of the door there?
Nice. Exactly. Okay, that's really important. We need to take note of the door, and we need to take note of where the door leads. So here's the door. You can only get into the house from here, which means you're going to go into the living room. Okay, so this is our living room. And then the next question says, in which general direction does the master bedroom window face? So here's the master bedroom, and here's the window. I even, without knowing it, highlighted it earlier. So here's the window of the master bedroom. Now take note of the fact that I have given you a compass direction on your map. Generally speaking, we do that. I'll talk a little bit more about this in a second. But who can tell me in what general direction?
Would it be east?
Okay, so I'm definitely in agreement that east must feature. So just remember, we've got, the only way I remember this, guys, and it's quite embarrassing, is like how I learned in primary school. Naughty, elephants, spray, water. Do not know my compass directions if I don't say that, which is a little bit embarrassing, but it's fine. So I agree, east must feature, but do you agree if we now take this compass and we sort of look at where the window is, it's kind of in the middle of those two. There's the window and it's facing out that way. So do you agree it would be a combination of north and east?
Yes.
Okay, good. Right, so just be careful of that, particularly when the compass is like a bit skewed. Just take note of it. And like I say, I'm sorry you had to hear me say naughty elephants, but I don't know it otherwise. Okay, so northeast, that's the way it's facing. If they really wanted to, and this would be a question that we would probably ask you more in trial exams than in finals, we could maybe ask something along the lines of like, do you think that this is a good position in the house for a bedroom? We could ask you something along the lines of whether or not you think having a northeasterly facing window would be appropriate for a bedroom. This is asking a lot, and you do talk about this when you talk about floor and elevation plans, but not a lot. So like I said, it is asking a lot. But then you talk about things like sun rising in the east, setting in the west. You would get a fair amount of like morning to afternoon sun, but then it would be quite cold in the evenings, etc., etc. Like I say, not really a question we usually ask, but it is something that they could ask. So just have that somewhere in the back of your minds. Right, 2.4 says one of the door locks needs to be changed. Write down, and this is where probability usually gets thrown in as a random last question to one of our questions. One of the door locks needs to be changed. Write down the probability in simplified fractional form that it is not one of the interior doors. Okay, so importantly, they've told us exactly how they want us to write our answer. So we know that a probability can be written as a fraction, as a percentage, or as a decimal. And they have very specifically told us that it must be in fractional form. So if it's not in fractional form, it means that they are going to take off a mark. So just make sure that you are writing it down properly. And then it says, well, then we actually need to go and answer our probability question. Now, this is a little trickier because it says write down the probability in simplified fractional form that it is not one of the interior doors. So now we just need to be mindful of where the interior doors are versus where the exterior doors are. So let's start with the interior doors. So I'm going to highlight those all in blue because I've already got the blue. So interior doors would be all the doors inside the house, okay? Specifically inside the house, not leading to the outside at any point. So there's 4 interior doors. I then can consider my exterior doors. Basically, that's what I'm looking for. If it's not an interior door, or if it cannot be an interior door, it has to be an exterior door. So we've got the door leading in from the outside to the kitchen. And as we said earlier, the door leading in from the veranda. So that means if it has to be not an interior door, it has to be an exterior door. And we only have 2 of those. So the probability of exterior door, or I suppose you could say not an interior door, is 2 out of 6. And it said simplified fractional form, so we would simplify that to a third. Alternatively, you could have gone and said, okay, well, I know that all my interior doors, or of all my doors, I have got 4 interior doors. So you could say probability of not an interior door would be all of my doors, which is 1. Remember, all is represented by 1 or 100% in probability, minus the 4 out of 6 interior doors, which gives me 2 out of 6, which simplifies to a third. So either way, you get your answer. I prefer to go with counting then all the doors that are not interior, so just looking at the 2 out of 6, but it really doesn't matter. Makes absolutely no difference. But for this question, it was very important that we did identify which doors were interior and which doors were exterior, because it very specifically told us that it did not want an interior door. Now, again, we've spoken about the fact that 4 marks seems like a lot of marks for a question like this. Realistically, you could have gone straight to your answer here, okay? But always bear in mind that we're generous with marks, and particularly in questions like this where you are needing to read or get information from a diagram, from a table, from a graph, whatever the case may be, we give you marks for writing down the appropriate value from that graph, table, diagram, whatever. So a mark is allocated sorry, I don't know where my brain was going. Let's try that again. 2 marks are allocated for the 2 doors that are not interior. 2 marks because you would have to differentiate between interior and exterior. So there's a bit of work that you would need to do to get that. A mark for your denominator, so understanding that in total there were 6 doors, and then that final mark for simplifying your answer to a simplified fraction. Because it gave you that instruction in the question, this mark is obviously very important, and you will lose it if you have not simplified. So if you left your answer as 2 over 6 or 2 out of 6, you would lose the mark. Granted, you're still getting 75% of the question right, but it's silly to not get 100% just because you didn't simplify. Okay, on the flip side, a mark for understanding that 4 out of the 6 doors were interior, understanding that you needed to subtract 1, all of the doors, minus the 4 interior doors, a mark for the 2 out of 6, and a mark for the simplification. So the mark allocation generally is generous. And like I say, particularly when you are working with a diagram or a table or something like that, where you're reading values off of it, don't get like flustered by the mark allocation, because often there's going to be mark allocations for you reading values off a table. As you go through past papers, you might see next to a mark or next to a tick or something like that, RT. That means read from table or read from diagram. You basically took information from the diagram, you read it, and you used it. So don't get panicked. Just because it's 4 marks doesn't mean I need a lot of working out. Okay, and this is kind of what I was saying earlier in 2.5. Jan remarked that the kitchen gets a lot of sunlight. Critically comment on his remark. Okay, so there's a few things that we just need to understand before we get into this. Critically comment is basically tell me whether he's right, and then give me a reason why he's right. Don't just be like, yes, Jan is right, or no, Jan is wrong, or whatever the case is. Tell me why. Tell me why you think that this is not a correct answer for the question. And this goes back to what I said earlier. So again, it's not great artwork, but we don't need art. Remember, the sun rises in the east. So here's my sun. The sun rises in the east. So the sun is rising here on the veranda. So the veranda is in a lovely spot. Early morning coffee, lovely, great. We can watch the sunrise. In terms of where the sun is going to set, the sun sets in the west. So let's maybe just write that there because I'm not going to draw sun again. And if we think about where this kitchen is situated, it's definitely on the westerly side. But think about the windows. There's one tiny little window here at the back, okay? And there's a window here on the side. But the problem is where this window is located, this is in the south, okay? There's not going to be any sun really. There's this tiny little window that's going to let in a little bit of sun into the kitchen, but not a whole lot. And so if we are going to critically comment on his remark, I would say, no, Jan is wrong. For all of the reasons I've just given, which I will put down in bullet point form, because I think if I had to write it out, you would just fall asleep. Okay, but again, understand the positioning of your house in relation to things like the sun, morning sun, evening sun, where the sun rises, where it sets, etc. So as I said, the kitchen is on the south, or the kitchen is on the southerly side. I don't think that's actually a word. Let's go southern side. Which therefore means not a lot of sun. Okay. Obviously, again, full sentences. Write out your reasoning logically. But you're going to get a mark for saying, no, he's wrong, or yes, he's right, and then 2 marks for your reasoning. Obviously, you can phrase it in a whole bunch of different ways. So you could have said something like the window for the kitchen that would allow sunlight in is incredibly small and maybe hindered by the walls of the bathroom to let sunshine in. You could say something like the only window that allows, or the only window that is not blocked by another room is the window on the south, which doesn't let in a lot of sun. You could have said something along the lines of I'm trying to think what else I said. The sun sets in the west, and so he might get some late afternoon sun, but not a lot of sun anywhere else, and so the kitchen would actually be very cold throughout the day, etc., etc., etc. All of the things that I said earlier, you could put into a statement and you will get your marks. But again, just something to bear in mind. And like I say, just think about where the sun rises, where it sets. And if you need to draw a little sun on your plan like I did, do that so that you can understand where the sunlight is coming in and where you're not going to get any sunlight in your house, in your building, in your construction, whatever the case may be. All right, 2.6 asks, give one reason why the windows shown in the above drawing do not represent windows of the kitchen and dining room. Okay, so we're just going to read that sentence again. Give one reason why the windows shown in the above drawing do not represent the windows of the kitchen and the dining room. Okay. Let's just go to the kitchen. Oops, sorry. Sorry, guys, things are going astray here. Oh, we're getting there, we're getting there. Right, so here are our windows shown on our plan. Let's hope this continues to work. Windows, 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 etc., etc. Here's our dining room. And the question is asking us to refer to the dining room and the kitchen. Okay. I'm going to be honest, I don't know if I understand this question. Anyone understanding it better than me? Give one reason why the windows shown in the above drawing do not represent the windows of the kitchen and the dining room. I understood it when I put this all together, but now my brain's gone. Okay. So this is where it helps to read your question with understanding. It says in the above drawing, not the above plan. Aye. Okay, so above drawing. Here's the above drawing. What a nincompoop I am. Okay, so drawing. Let's read it again. Give one reason why the windows shown on the above drawing do not represent the windows of the kitchen and the dining room. So these windows on this drawing over here, they're asking me why do they not represent that of the kitchen and the dining room? And now we have to kind of use both drawing and floor plan in unison together to try and figure out what's actually been shown here. Now, if we look at the drawing, would you agree with me that we've got like an overhang here? So this bit over here is hanging over the front of the house, and this would be considered, okay, granted, not that big a space. So because of that overhang, this is our veranda. And we said here, it is an open area with a roof over it. The overhang is the roof. So this is our veranda portion of our house. It also makes sense because we said earlier that this door over here goes from the veranda into the living room. And we saw that on the plan. Here's our veranda at the front of the house. There's the door leading straight into the living room. And so this window over here would be the window for bedroom 1. And so now we need to reason all of that, why those two windows do not show the windows here for kitchen and for dining room. And this is where the veranda information becomes very important, because do you see that we still have a door from the outside into the kitchen? So this door may very well have been the door from the outside into the kitchen. But the fact that we have this veranda, this overhang in the front, tells us that it's not that side view. And so I would say exactly that, once I finally understood the question, that the drawing shows the veranda. And this is not outside the kitchen or dining room. Completely forgot we actually had a drawing, despite the fact that we spoke about it. Sorry, brain fart. All right, so and it's exactly what I said earlier. I clearly don't listen to myself. Oftentimes your floor plans and your elevation plans need to go hand in hand. You need to work with them both at the same time to understand certain properties or characteristics of your building or your construction or whatever it is, and how they might link together. So you need to be able essentially to work with the floor plan and elevation plans and basically be able to put your elevations on your floor plan to understand what the outside would look like on all 4 sides of your house or building, office, whatever the case may be. We often don't give you all elevation plans. We give you 1 or 2. 2 is even a stretch. It's usually 1. And we would ask you which side of the house, the school, the office, the space, whatever, does this elevation plan fit on in relation to your floor plan. So you do need to be able to work with them side by side or together. Right, this is now where scale comes in. Like I say, what we need to bear in mind is that we need to often measure, and we need to be able to work with conversions or just general scale work. So the scale used for the floor plan is 1 centimeters representing 1,000 millimeters in real life. So every centimeter we measure on the floor plan represents 1,000 millimeters in real life. Now, 1,000 millimeters is a little bit random. Why? Who knows? But it's going to be important when we get to this next question. So it says, write the given scale in number scale format. Remember, you've got two types of scale. You've got number scale, where it's 1 is to some value, and then you have your bar scale. So your bar scale is generally like 1 centimeter, 2 centimeters, 3, 4, and that represents, I don't know, 250 meters, 500 meters, etc., etc. And you would measure your bar, and then once you had a measurement of your map, you could say, okay, well, every bar that I measured represents this many meters, kilometers, whatever, and we can go from there. Sorry. Okay, so you've got two types of scale that you need to work with. I can't say that we work with one more than the other. We don't. It's very much a case of whatever your examiner decides to work with. So you need to be comfortable with both. Sometimes it's a bar, sometimes it's a number scale. It really depends. Okay, so it says in number scale format. Now, what the most important thing is here that we need to remember is that my units must be the same. For a number scale, your units must be the same. You have no choice in the matter. Has to be the same. It's a case of 1 unit on your map represents however many of the same unit in real life. So that's going to be the first thing here, because we were given 1 centimeter is equal to 1,000 millimeters. I don't want that. I need my units to be the same. So I need to do a conversion. Does anyone remember how many millimeters there are in 1 centimeter?
Is it 10?
Good. Okay, 10 millimeters. Now, again, guys, this is one of those things where if you know you just divide by 10, that's great. If you weren't sure, use the little crisscross trick method, divide up times across. All right, but this is a relatively easy conversion. But again, we have methods and we've spoken about different methods to use. So we would just divide by 10 and we get 1 centimeter equals 100 centimeters. My units are now the same, which means I can actually drop them. And so this number scale that is used for the plan is 1 is to 100. Every 1 centimeter I measure on my map is equal to 100 of that same unit, 100 centimeters in real life. So the important thing for number scales is your units has to be the same. As you can see for a bar scale, they don't. I've got 1 centimeter at the bottom and meters at the top. I don't care if the units are the same or not because you're measuring blocks. But when it comes to number scale, they must be the same in order for you to be able to correctly use what you need to do or correctly use your scale. All right, so this is now where you would need to measure. So it says measure the inner length of bedroom 2 and use the given scale to calculate the actual length in meters of bedroom 2. So we'll get to all of that stuff now. Inner length, let's just make sure we understand what that means. When you take your ruler and you measure, you want to measure from the inside of these dark lines. So not from the outside, from the inside. Inside all the way to inside, not outside. Now, obviously, you might not have the paper printed out in front of you, which is absolutely fine. So I'm going to tell you what it measures. This measures about 4.5 centimeters. There is always some leeway with your measurement. It's usually between 1 up and 1 down or 2 up and 2 down. It depends how much of how much uncertainty there is between your measurement. So sometimes, for example, on your strip map, if they say, for example, I asked you to work out a scale and I told you to use between Clan William and Citrusol, some people might measure from the outside of the circle. Some people might measure from the center of the circle. Some people might measure from the inside of the circles. That's going to give you a whole bunch of different measurements. So generally there is some margin for error. If you do get something like this where there's like a big circle, a big square that you're needing to measure from, go from the middle. Okay, always go from the middle because that's sort of like the halfway point between the extreme end and the extreme inside. Just go in the middle. This one, not so much because of the fact that the lines are relatively thin. But again, there will be a room for human error. Like every now and then we make mistakes and it is a human measurement. So we just need to be mindful of that. But like I say, this gives us a measurement of roughly 4.5 centimeters. So that's my measurement. And you get a mark for being able to use your ruler and measure. Right, what we now need to do is we now need to convert this to meters. And we need to use our scale. Now, remember our scale was that 1 unit on our plan or our map is 100 of the same unit in real life. Now, again, if you're not comfortable working with scale, use the little trick method, okay? So we have got our plan measurement, and we've got our real life measurement. I'm just going to say RL. Our plan measurement is 1:100, so we use our scale as our first step, and it's kind of like what we were doing earlier. You put the conversion first, we put the scale first, and then we write down this measurement under the appropriate heading. Now, this was a measurement I took off the plan, so that must go under the plan. Then I use my little divide up times across trick so that I can get what my real life measurement would be. And so I'm going to have to say 4.5 divided by 1, which is 4.5, times 100, which is 450. Now remember, this is 450 centimeters because it's a number scale. Units are the same. What I now need to do is I need to go back to my question and say, okay, cool, it wants it in meters. So now I need to convert from centimeters to meters. Does anyone remember how many centimeters there are in a meter?
Is it 100?
Yeah, good, 100. So there are 100 centimeters in 1 meter. Again, if you're not super confident with that conversion, do another little table. It is just a division by 100. But again, if you're not sure whether you should be dividing or timesing, just use the trick. That's why it's there. It's supposed to make our lives easier. So we draw a little table for ourselves, obviously better than whatever that was. Okay, it didn't get any better, but it's fine. And now we put in the measurements that we're working with, meters and centimeters. We put down the conversion, 1 meter to 100 centimeters. We are converting 400 centimeters. And again, this is why, guys, this trick method is so useful. I don't need to think about anything. I quite literally just put it in there, put it into my table, and go. So I'm going to divide up 450 divided by 100, and then times that answer by 1. 450 divided by 100 is 4,5. So the inner length of bedroom 2 is 4.5 meters. Right, and again, this is why this little table trick method is so useful. I don't need to think about what operation I'm needing to perform. The only thing I need to do is know what the conversion is. Whether it's the scale or whether it's a conversion between units, that is the only piece of information you need to know. Everything else you put into the table, divide up times across, and you're going to get your answer. Obviously, you don't have to use this, and we had the conversation last week. I think Atia, you asked, I could be wrong, about whether you need to show both methods, and is it necessary to have all these methods going on? No, pick one. If you don't like this method, use the method you're comfortable with. I did say that if you would like to be extra sure, and you should always show what operation you're doing, write in your divide up times across, or write in your operation, because then your marker can see what you've done. They can follow your arrow so they can see what you did. But that's it. That's all you need to do. But again, if this is not something that you're comfortable with or something you don't like, you don't use this. You just do the normal multiplication and division. All right. We then have Jan stating that the given scale is not very accurate to use if photocopies were going to be made of the plan. Again, we're going to critically comment on a statement and give a reason. So who can tell me why, or who can tell me whether or not they think Jan is correct or not? And if you can give a reason for why you think he is or isn't correct, that'd be great. This is going to go back to what you remember about the accuracy of scales.
Ma'am, isn't it because, okay, um, wait, yeah, okay, isn't it because when you make photocopies, um, you can make them in different sizes, which then will change the scale size also.
Exactly. Okay, exactly. So unless you are making a perfect photocopy and you're not changing the size in any way, absolutely. The problem with a number scale is that a number scale is only accurate for a very specific size of your diagram. If I made that diagram even a smidge bigger, the number scale no longer applies. So that is the problem with number scales, and we'll chat about then why bar scales are more beneficial. But let's just write this down. So Jan is correct. And it's exactly what Ati has just said. When you make a photocopy, the size might change. Obviously, again, full sentences. So you would say, when a photocopy is made, the size might change, which means your scale is no longer valid. Okay, now guys, this is something that's really important to remember with number scales. Accurate. The second the size of your image changes, it's no longer going to be a valid scale. Now, let's say, for example, let's say you had this as your bedroom or whatever it was that you're looking at, and you were given a bar scale. Okay, so here's my bar scale. Obviously not a very good bar scale, but there it is. What we need to bear in mind is this bar scale is a picture. Okay, so if I took my bedroom and I enlarged it, do you see how the bar scale got bigger as well? If I made it much smaller, my bar scale is going to get smaller with it as well. My bar scale always remains in proportion to my diagram. And so for a bar scale, this is way more useful if we're going to resize pictures, because the bar scale changes size with the diagram or with the image. And so if we were to be asked, let's say for example, this question, it asks something along the lines of, Jan made photocopies of his plan and made it twice as small. Which scale would be more useful, or which scale would be accurate? We would then say a bar scale, because it is resized with the picture. And so its proportions remain the same with the map, with the plan, with the diagram, whatever it is we're working with. So that's just something to bear in mind. Unfortunately, a number scale doesn't do that. You would have to find a whole new number scale for your plan. But bar scales, we don't have to do that because it is a picture. So it resizes with the picture, and we then don't have a problem. Okay. So just something to bear in mind. I also realized, guys, I have not stopped at any point to let you take screenshots. So I do apologize. That is on me entirely. So let's just go here for this first one to do screenshots. Make this much smaller so you can see everything. And then I'll go back down. Okay. And then here is the first little bit, and then I'll scroll down to the next. Let's do this so we can see everything. Okay, and then this is the last little bits. Sorry, I just got so carried away with our plans. All right, so what you can see is that even though this is question 2, so a question specifically focusing on the maps and plans, it's not a particularly hard question. Granted, it helps when you can understand what the question is saying to you and remember that you were given 2 drawings and not 1. That's me. But none of this was hard. Obviously, it relies on or is determined on whether or not you know your stuff. So there is a fair amount of like studying in terms of where does the sun rise, set, compass directions, working with scale, etc., that you need to know. But none of these questions were hard in terms of your ability to answer them. If you know your stuff, this is easy. Okay. So I do understand that sometimes the language in these questions, and particularly like in MathsLit, sometimes it is a bit confusing, but just read very carefully, very slowly. If you're not sure, leave it out. You can come back or give it your best shot. Like those are your two options. So for example, the 2.6, if like me, it took you a little while to realize that there were actually two diagrams, I would have just gone with my best guess and tried. Okay, because often with those types of questions in particular, where the language is maybe a bit funny, often that's asking for give a reason, critically comment, justify, something like that. And there will be about 5 to 7 alternative answers, and you might just hit one of them on the head. All right, so when in doubt, try your best, otherwise move on from it. Generally speaking, those questions are 2 or 3 marks in the greater scheme of things, not a huge chunk to leave out 2 marks rather than leave out like a 4-mark question, like 2.7.2. But as you go through more past papers, hopefully you will get the hang of the language used in these types of questions. Okay. So let's have a look here. Hang on. Sorry. Right, so this was from 2 years ago, trial paper. And again, a map being given to us on an annexure. So always have your annexure ready and looking at what's happening. This was not the map I was thinking about in terms of a national park, but here's another one. Okay, so a couple from Netherlands decided to have a 3-day vacation at the Mapungubwe National Park in the Republic of South Africa. Annexure A contains a map that they used to get to the Mapungubwe National Park. So here's the map. One thing I want you to notice with this map that's a little bit different to the other map the strip map that we looked at, is there's grid references here. So just be mindful of that. And we do have a north-south compass direction here, so we could put that in as we go along. In the map, they've given us a whole bunch of sort of different towns, areas that we're traveling along. The lines are labeled with the road as well as the distance. So basically what this is saying is that the distance from one point to the next is 107 kilometers. And that is then consistently done throughout this map. All right, so first question says give, and again, it's got a grid reference, so use it. Give the grid reference of the Vembe Trails Campaign Initiative trials. So obviously we first need to figure out where that is. And this is now where our key becomes important. So if you go back down, or if you go down to your key, we can see that D represents the camp. And so we need to find letter D. There it is. So who can give me the grid reference? Usually we start with the letter.
A3.
A3, excellent. Okay, so letter first, then number. It is in row A, column 3, and we can see it there. 2.1.2 says identify the provincial road between Musina and the Mapungubwe National Park. So again, go back to your map, identify the important points that the question is referring to. So there's Musina, here's the entrance. What is the national road? Now, it might not be labeled in between those 2 points, but look along your map. This road all the way along up here is the same road that we're traveling on. So what is that national road? Who can tell me? And I actually said it earlier.
It's the N1.
Good. Okay. It would also help if I read the question here. Provincial road. Here, name the national road. I don't know if my brain did that. So N1, absolutely. Oi poloi. The question we were actually trying to answer, identify the provincial road between the two. R roads are provincial roads. So this is the road in between them, the R572. Again, guys, read the question. That was on me. I don't know if I just read half and half. You can tell me if you were listening, but there we go. Okay, so provincial roads generally have an R, national roads have an N, and then numbers after them. Been a day, hasn't it? I feel like it was a day last weekend as well. Something went terribly wrong last week as well. Anywho, 2.1.4 says, in which general direction is point drift from Pretoria? So again, we go back to our little map and we identify these places that we're needing to work with. So here's Pretoria. Point. They spelled it differently on the map and in the question, but anyways, that is a bit problematic, but it's fine. Those are the two places that we're looking at. And remember, north is straight up. So think about the fact that we're working with a diagonal thing or diagonal sort of relationship. And again, important to read the question because it says, in which general direction is point drift from Pretoria? So you are in Pretoria, you're looking to point drift. What is the general direction? And that's really important, that from.
Ma'am, would it be northwest?
Exactly. Okay, northwest. So from Pretoria, looking up is northwest. Remember, naughty elephants spray water. Naughty elephants spray water. If we follow that direction, it's in a northwesterly direction. Absolutely. If it had been the other way around, in which general direction is Pretoria from Point Drift? It would now be southeast because we're going from Point Drift down to Pretoria. So always very important that you read where you're looking from and to and getting your directions right. Right, 2.1.5. I know this is probably one of the silliest questions to hate because it's such an easy question to answer, but I hate these questions. Don't know why, I really don't enjoy them, but they are one of the easiest to answer. So it says, describe using towns and or route numbers as references two possible routes from Pretoria to the Mapungubwe National Park. So 2 routes. Now, this is why it's 6 marks, because you're going to give 2 routes. So it's likely going to be 3 for each, which it is. But we need to basically get from Pretoria to the national park. So here's Pretoria. Here's the national park. I need 2 routes. Don't care what the routes are. So you can give me one.
Ma'am, so wait, does your answer have to be in detail? Like,
yeah, this is why I hate these questions, because you do need to give detail.
okay.
Just do your best. I'll fill in the rest.
From Pretoria, you would take the N1.
Okay.
And go, can I say through, like go through Polokwane.
Good. And go.
I don't know how do you say this, the second one.
This one here, Mikado.
Yes, that one.
Okay.
Through that one. And
so, yeah, keep going.
Continue through Musina. Yeah.
Yeah.
And then get into the Mapungubwe National Park.
Perfect. Okay, so continue along the N1 through Mikado and Musina, and then continue along N1 to the park. Obviously, you would put the name of the park. I'm just lazy and I'm not going to do that. So, as Atia said, try and be as descriptive as possible when you give it your routes. You could even go a step further in terms of what I've written here, and you could say, take the N1 from Pretoria and go through Polokwane, a distance of 260 kilometers. Continue along the N1 for another 107 plus 92 is for another 201 kilometers, taking you through Mikado and Musina, and then travel the remainder of the way along the N1 into the park. Okay, so be as descriptive as possible. And I know this probably seems like a terrible thing to say, but basically treat your marker as if they can't see the map. So I don't have that map in front of me, but I need you to describe to me what I need to do. I need to be able to get to where I need to be without the map. And this is why I'm saying be as descriptive as possible. Even if you think it seems so silly to write down 260 kilometers from Pretoria to Polokwane, put it in there, right? Because again, if I was trying to do this without a map, I would need to know how far I would need to travel from one point to the next, right? So always be as descriptive as possible. Treat your markers if they can't see the map. You need to give all of the detail possible. Right, I'm not going to write a second one because, again, I'm lazy, but you would have to. No, I suppose let's write the second one because it does say give 2 possible options. Right, so a second option, again, it would be completely up to you. I'd probably go Pretoria, Polokwane, through Dendron, Vivo, all days, then go up the R2521, I think that is, yep. To the Venetia mine, all the way up until I meet the R72, take a right, and then into the park. Okay, so there's a few different routes you can take. Just because I've chosen that one doesn't mean that's the one you have to take. But again, we would be as descriptive as possible. So again, from Pretoria to Polokwane, travel along the N1, travel 60 kilometers along the R521, to Dendron, another 40 kilometers to Vivo, and then another 50 kilometers to All Days. At the fork in the road, go to the right, or you could say head north because you do have a compass direction for 22 kilometers, and then go right along, we don't have a road name here, but along past Venetia mine, all the way to the R572, another right, and into the park. Right, so again, be as clear as possible. I need to be able to get to where I need to be without this map. Just quickly, if I do not give you compass or a compass direction, please don't use north, south, east, west. You don't know where those are. And so rather than use left and right. However, if I do give you north, south, east, west, or some sort of compass direction, feel free to use head north, head south, whatever. I see, and like, again, this is like kids that I've taught, so very small group, but often they will say head north, and I'm like, well, where's north? I haven't told you where north is. And so unfortunately, we'd have to mark you wrong because you've made an assumption about where north is. North is not always straight up. We saw that in our plan here. North was diagonal, so you cannot assume that's where it is. I would need to give it to you. Okay. 2.2.1 is a scale question. So it says, South African friends of the Netherlands couple departed from Pretoria at 4:30 a.m. to spend the holiday with them. Their journey is described as follows. On their way from Polokwane, they took the turnoff to the R521 route. They rested for 45 minutes at Dendron and took 15 minutes to do some shopping and fill up the car's fuel tank at All Days. So if we just quickly map out their route, because obviously that route is important to us or important for us, otherwise they wouldn't have given us that whole story. They left from Polokwane, okay? So that's their starting point. On their way from from Pretoria, it would help if I read the question here. From Pretoria, on their way from Polokwane, they took the turnoff on the R521 route, so we're along here. They took a rest for 45 minutes over here. And then when they got to All Days, they did 15 minutes of shopping and then filled their petrol tank. So that thick red route is what they followed. It then says, if the scale of the map is given as 1:3 million and the distance measured on the map between Beitbridge and Messina is 1.3 centimeters. I don't see Beitbridge unless I'm a bit stupid. Anyone see it?
No, man. It's
Okay.
not on the map.
Okay, cool. That makes me feel better. Thank you. I assume they're just telling us that information. That's fine. Right. So they've asked us to calculate in kilometers the actual distance between Beatbridge and Messina. It's fine. They've given us the measurement, so we don't actually really care where it is. We have the measurement. Now remember, we've got 1:3 million as our scale. That kind of makes sense. Okay. Remember, if it was 1 centimeter, the distances that we're working with here are in kilometers and hundreds of kilometers, some of them. That scale does need to be quite big. Right, and again, this is where if we're not super comfortable with scale, use the little trick method. There's no reason to try and overcomplicate this and do fancy things when we have this little trick method that we can use. All right, so we are trying to go from a map measurement to a real life measurement. So map to real life. Our scale is 1 unit on the map is 3 million of the same unit in real life, and we can do a conversion a bit later. We will deal with that. And we know that our map measurement is 1,3. So we're going to divide up. We're going to times across. And essentially 1.3 divided by 1.3 times 3 million. That is going to give us 39 million. I don't know why I'm writing it there. I do apologize. Right, 39 million centimeters. Now, quite clearly, they've asked us for the answer in kilometers. And this is, again, where knowing your conversion is super important. But I'm also fully aware of the fact that the conversion from kilometers to centimeters is not super nice. This is where King Henry could become involved. So King Henry died a miserable death called measles, or you must just learn this conversion. That's completely up to you. But we are wanting to go from centimeters to kilometers. That's a lot of jumps. Remember, we're going small to big. So that means we have to divide. So we're going to divide by 10, 100, 1,000, 10,000, 100,000. So what this basically means is that 1 kilometer has 100,000 centimeters in it. And if you remember from last weekend, I gave you, and I put it on the Google Classroom as well, so if you've forgotten it, is there. I gave you that conversions you need to know table. This is one of the conversions that I put on there for you to know. And I said specifically that it will be helpful for the maps and plans section. So I would learn this because it is very helpful in this section. But if you don't remember it, then King Henry is your guy. So we now need to go from 39 million centimeters to kilometers. Again, we're going from small to big, and we've just discussed this. You would have to divide by 100,000, or again, use the table method. That's absolutely fine. It's there for a reason. Now, guys, when you're dividing by multiples of 10, you basically just move your decimal. So you don't even need a calculator. Here, my decimal is at the end of the number. I need to move it 5 places. And because I'm dividing, I'm moving it to the left. So the number of jumps that we did is the number of times I move it. 1, 2, 3, 4, 5. I cannot do math here. 10, 100, 1,000, 10,000, 100,000. Oh, because I can't do math. It's 3.9 million. Here we go. 3.9 million. There we go. And so we move it 5 placeholders back, and we get that this would be 39 kilometers. That would be our distance. All right, so like I said, this is a conversion that I definitely recommend that you learn. And if you don't learn it, you're going to have to find some other way to remember it, whether that's through King Henry or just Pope. But this one is particularly useful for scale work in maps and plans. Okay. Yeah.
Wouldn't the answer be 390 kilometers?
So I was silly earlier. Sorry, it's not 39 million. It's 3.9 million. I had an extra 0 in there. That was me. Okay. Sorry. Yeah. I put in an extra 0 accidentally. I do apologize. Okay. So yeah, like I said, knowing this conversion, very, very useful, and how you choose to do that is completely up to you. All right. It then says determine, showing all calculations, the distance from Pretoria to Mapungubwe National Park as it appears on the map. So what they mean by that is add up all of your distances. Now, what we would need to be mindful of is that we're talking about the route that they've taken. Okay, so along the R521. So we'd have to add 260, 60, 40, 50, 122. Where are we? The 23, and we'd have to keep adding. Basically, you're adding distances. Okay, that's all you're doing. Just add your distances and you're going to be absolutely fine. So very basic question. And I don't know if we might have time for this. I think we will. Because I'll ask you now. So this is a question that I mentioned earlier, and we did actually do an example. I added in a question. In terms of, in questions like this, particularly where there's some sort of travel by car involved, this is where speed distance time is going to come up. And here, prime example of a speed distance time question coming up where I'm asking you this. Now, it is an 8 marker, which is wild. But it's just because there are a few things that we need to take into account in terms of like the route that they're traveling, etc., etc. The stoppages that they made, the 15 minutes, the 45 minutes, etc. All right. But again, if you read things carefully and you do things carefully, you're going to be absolutely fine with a question like this. And remember again that even though it's 8 marks, we're generous with our marks. All right. So again, I am aware of the fact that I am past our 4 o'clock endpoint. So if you would like to stay on and I will do this question, you're welcome to, but I'm also absolutely okay if you need to leave. There is no hard feelings. What I'm going to do is just do this so you can take a screenshot and then I'll scroll down. Okay. And there we go. Right, would anyone like me to do this question for 8 marks? Bearing in mind that it is 5 possible.
Yes, please, ma'am. Please.
Okay, cool. All right, so again, guys, if you need to leave, it's absolutely fine. No hard feelings whatsoever. So it says the South African friends traveled at an average speed of 120 kilometers per hour between Pretoria and Mapungubwe National Park, aiming to arrive at 10 a.m. Now, bear in mind, they left at 4:30 a.m. They had the 45-minute, whatever that was trying to be, rest, and the 15-minute shop petrol break. And they want to get there by 10 o'clock. So from 4:30 to 10 a.m., that is a 5.5 hour gap that they have to get to the national park. So it says, also considering all stoppages, so these stops that I've just mentioned over here, show with calculations whether they will make it at the same time. All right, so the distance from Pretoria to the national park, this ended up when you added all your distances together being 478 kilometers. Like I said, easy peasy, we're just adding. But we obviously now need that into this question because we've got a distance, we have a speed, and that's going to help us find time. So again, time is equal to distance over speed. Use the triangle. I find the triangle very, very useful for these questions because then you don't actually need to know the formula. It does give you the formula, but this is in terms of distance. So you would have to solve the formula. And this is why I like the triangle. So speed is distance over time. We're looking for time, so it's distance divided by speed. So our distance was 478 kilometers divided by the 120 kilometer hour speed. Guys, you don't have to put the units in. I don't know why I've put them in. You can, you don't have to. Basically what happens is the kilometers divide each other away, and that's why you're left with just hours for time. Okay, when you divide 478 by 120, you get a recurring decimal of 3,98 and then 3333333, and so it keeps going, hours. Now this is where things get dodgy, particularly when it comes to time, because the expectation is that you know how to convert this. So there's two parts to this number. Part number one, okay, aggressive. Part number one is the whole number. So this is 3 full hours. The decimal is part of an hour. So it's saying 3 full hours and 0.98333333, etc. portion of an hour. And this is what we would need to be able to convert to minutes. Now remember, 1 hour has 60 minutes. So what we would want to do is take the 0.983333 blah, 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 and times that by 60. Figure out how many minutes there are in that portion of an hour. And that gives me about, it's 58,99, etc. So it's about 59 minutes. We don't expect you to go into seconds. That would be ridiculous. Right, so it's about 59 minutes, which means that just the drive time, so just the time they actually spend driving takes them 3 hours, 59 minutes. We then have to take into account the stops. So we've got 3 hours plus 59 minutes, plus the 45-minute rest that they took, plus the 15-minute shop and petrol break. Now, 45 plus 15 is a full hour, so this takes me to 4 hours and 59 minutes. Now, remember we said that they left at 4:30 and they want to get there by 10. And this is a total of 5.5 hours. If we now compare the 5.5 hours to the amount of time it actually takes them, they are going to arrive with 31 minutes to spare. And the question says, show with calculations whether they will make it at the same time. So yes, they will make it by 10 o'clock. So it's really important that you do know what the time difference is between when they left and when they want to arrive, and then obviously take into account your calculations. So again, this is not like a lot for 8 marks, but there was a fair amount that we needed to do, hence the 8-mark allocation. So you're getting a mark for substituting the correct values into your formula, a mark for getting your time answer. You're then getting a mark for converting those or that decimal into minutes. You then get a mark for adding all of your times, taking into account the rest. So this is already 4 marks. And you get a mark for getting your total time of 4 hours, 59 minutes. You then get a mark for, sorry, my brain just stopped. You get a mark for taking into account what the time would be in terms of if you left at 4:30 and arrived by 10, how much time would or is allocated to you to your travel in that time period. And then you get your mark for saying that, yes, they will arrive on time. You actually get 2 marks here, sorry. 2 marks for taking into account. You don't have to have done this calculation in terms of when they left and when they arrived by like this. What you could have also said is, if you know, let's just do this. So if you know that you leave at 4:30, and if you know that it takes you 4 hours and 59 minutes, you could add that on. So I'm going to do this step by step because this is how I find it easier. If we add first the 4 hours, that takes us to 8:30. And then we add our 59 minutes. That takes us to 9:29. And so we can see that we are getting there before the 10 a.m. cutoff. So you could have also done it like this and worked out that when you add on all your travel time, your rest time, etc., you do get there before 10 a.m. And so that would be those 2 marks as well. You could have done it either way. doesn't really matter. It's up to you. Either you work out 4:30 to 10, or you work out once you've added your travel time, when you will arrive and the fact that you will make it before 10 a.m. There's often a few different ways to do these things. Right, but 8 marks for this question, and a lot of it to do with the actual calculations. That final conclusion mark is 1 mark. It's all to do with the calculations, and we said that already. So, for example, that question we had earlier with the probability in simplified fraction form, 3 of the 4 marks was just for your calculations. It's only 1 mark for the final answer. And so always just bear that in mind in terms of all the little things that you can do, the little parts working outs that you can do, even if you can't do the whole question, count for something. And so what I mean by that is if you forgot how to convert hours to minutes, for example, you still get 2 of the 8 marks for working out the time as 3,983 recurring. If you just worked out that from 4:30 to 10, that's 5.5 hours, that's another 2 marks. You've got 50% of this question just by doing part working out as you go along. All right, so just remember that, and just remember our mark allocation is generally quite generous. Don't think you have to have a page full of working out. So I'll leave that there for screenshots. If you've got any last minute questions, you're welcome to ask. But otherwise, guys, good luck. I know some of you are writing paper 2 this week, so best of luck. And yeah, hopefully we'll do this again before finals, and we'll be able to go through your mock exams, but really best of luck. I hope they go well, and I hope all your other exams go well. And then, yeah, ready for finals. Atia?
Ma'am, I don't know if you still have time, but there's this question in my prelim paper that I just wrote this week that I could not understand. So I was wondering.
Do you have the question?
Yes, I do.
Okay. Are you on the Google Classroom, have access to the Google Classroom at this moment?
Yes.
Okay, so you can pop it on there and then I can grab it. So on like the main page, there's like a announce something, post something to your class. You can upload the picture there and I can have a look.
Okay.
Just let me know when you've posted so that I can refresh.
Ma'am, do I put it on? Okay. I don't know.
I can show you. So
I'm in the Google Classroom, the MathsLive thing.
Okay, so mine's like the teacher profile, but it should come up just on the stream. There should be something like post something or comment something or whatever. And if you click on that, you can upload an image.
Okay.
Okay, and then I'll get it.
Let me try that.
Did you write a common paper, Atia, or was it set by your teachers? Do you know?
It's set by Sakai. So I don't know.
Well, that's okay. I will see. I will try.
Ma'am, I cannot get it. It does not show that. It doesn't look like how yours looks because it's on my phone. But I can read the question to you.
Go for it. I can
But
do
then
that.
there's an extra that, yeah.
What is the annexure? Is it like a...
It's a graph kind of thing.
Okay, read the question and I'm going to do my best. We'll see if we can figure this out without it in front of me.
So the question says, calculate the average time spent on eating and drinking for all countries in hours and minutes. And it's for 5 marks.
Okay, so I'm assuming the graph or the annexure that you have in front of you is like a bar graph or a pie chart or something?
Yes, it's a bar graph. Can I actually like on my camera and then show you the
Sure.
the thing?
Yeah.
How do I do that now? How do I see that it's showing?
Hang on. Can you... No, hang on. I think I'm being stupid. You would think that this would be an easy situation that's happening. Okay, I was being stupid. Is your camera on? There
Yes.
we go. Okay, no, I had my view the wrong way. Okay, I'm ready.
Can you see it?
I can see your ceiling.
Okay.
Okay.
Now can you see it?
Oh gosh. How do I make you bigger? Now you just get to see the top of my head, which is delightful, isn't it? Hang on, let me stop presenting for a second. Okay, I can see it. Right. Okay, so what was it? The average time that people spent eating and drinking in all countries?
Yes.
Okay, so what I would do, and it said in hours and minutes.
In hours and minutes, yes.
All right, so what I would do is I would probably go and convert all of my hours to minutes and get all of my times in a single unit. And the reason I'm saying that is because we know that to work out an average, I have to add all the numbers together and then divide by how many there are. If you're working in 2 different units, that just becomes complicated. So I would probably convert all my hours and I would shortcut this whole process. So I would add the hours. So it's 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 hours, which is, if I times that by 60, is 1,018 minutes. And then I'd add all my minutes. So I've got 13, 7, 6, 45, 40, 35, 33, 29, 24, 19, 16, 14, 12, 5, and 2. 300 minutes. Right, and so this is now my total. So I would add those two together, and that gives me the 1,380 minutes. Now what I would do, I would use that as my total because that's me adding everything together. So now I would say my average is the sum, so my 1,380 minutes, divided by how many countries there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15 countries, giving me 92 minutes. And then because my answer wanted in hours and minutes, I can convert this. And this is now a nice, easy conversion. 92 minutes is, so 60 minutes is a full hour, so 1 hour, and 1 hour and 32 minutes. That's the average time spent eating and drinking. Okay, so when you get questions like this, guys, particularly when it's 2 different units, and it often happens with time, convert everything to the same unit, do whatever calculation it is you need to do, and then you can convert back. I said it often happens with time. It's even like a measurement. So if we gave you dimensions, and some of them were in millimeters and some in centimeters, convert everything to the same unit. And then if you need to convert it again later, you can. Everything's then in 1 unit. But always work with the same unit in maps and plans and in measurement. It makes your life so much easier.
Okay, thank you, ma'am.
Okay. Pleasure. I also just realized that I did this whole calculation and wasn't sharing my screen. So
Oh,
well done, me. Ay. Okay, there we go. So that's how I would have done it. Converted the hours, added your minutes, divided by 15, and then all of that.
okay. Okay, it's quite easy. I did not do that.
I mean, you could probably do it with the hours. You could probably add up the hours, divide by 15, add up the minutes, divide by 15, and then put them together again. I just find it easier to work with the same unit, but it would probably work. Let's see. 18 divided by 15 is 1.2 hours. What did I say? 18 divided by 15 gives average hours of 1.2. 300 minutes divided by 15 gives you 20. And comma 2, so if we take 0.2 and we times it by 60, yeah, it does work. 0.2 times by 60 to convert that to minutes is 12 minutes. So 20 minutes, 12 minutes, 32 minutes, and 1 full hour, which is what we got, 1 hour, 32 minutes. So it works either way.
Okay. So, because I think I did add the hours, so I did get 18 hours.
Okay.
But I think I didn't change it into minutes.
So like I said, you don't have to change it into minutes. So this is if you did separate hours and minutes. So this is the hour calculation. This is the minute calculation. And then you can just put it all together at the end.
Okay. So would I still get my mark for the 18 hours?
Yeah.
Okay.
Because I would imagine the mark allocation is probably 18 divided by 15, 300 divided by 15, final answer.
Okay. Okay.
It's done. You can't do anything about it now. Focus on the next one.
Yes.
Don't stress.
But now I know how to do it, like if I do get in my final, so.
Exactly.
Yes. Okay. Thank you, ma'am.